Good day, everyone. The topic that we will be discussing for today is all about the different operations and functions. In this lesson, the different operations and functions are to be discussed, and along with that, the process on how we perform the different operations on algebraic expressions. But first, what are the different operations on functions? We have the sum, the difference, the product, the quotient, and the product of a constant and a function. So first we have is the sum of two functions. Given two functions, f and g, the sum of functions f plus g is defined by the equation f plus g and x equals fx plus gx. So before we go into the examples, please do take note of the steps in finding the sum of two functions. First, write the equation based on the given functions. Second, substitute the given values. And third, simplify. Here are the examples of the sum of two functions. Given number 1, fx equals 6x minus 1 and hx equals x squared minus 5x plus 4. Now we substitute f with 6x minus 1 and h with x squared minus 5x plus 4, and then we add and simplify. So the final answer is x squared plus x plus 3. Given number 2, hx equals x squared minus 5x plus 4 and gx equals x plus 5. We substitute h and g with the given values, which are x squared minus 5x plus 4 and x plus 5. That gives us x squared minus 4x plus 9. Given number 3, fx equals 5x plus 1 and gx equals x squared minus 9, let us substitute f with 5x plus 1 and g with x squared minus 9. And we have x squared plus 5x minus 8 as the final answer. Given number 4, fx equals 5x plus 1 and mx equals x plus 11. So we substitute f with 5x plus 1 and m with x plus 11. That gives us our final answer, which is 6x plus 12. Given number 5, px equals x squared plus 3x plus 2 and gx equals x plus 5. Substitute p with x squared plus 3x plus 2 and g with x plus 5. And our final answer is x squared plus 4x plus 7. Next operation we have is the difference of two functions. Given two functions, f and g, the difference of two functions, f minus g, is defined by the equation f minus g of x equals fx minus gx. These are the steps that we have to remember in finding the difference of two functions. First, write the equation based on the given functions. Second, substitute the given values of the functions and enclose the second function with a parenthesis. Then, we apply copy cha-cha on the second function. And third, simplify the values. Here are the examples of the difference of two functions. Given number 1, fx equals 6x minus 1 and gx equals x plus 5. We substitute the given values to the functions in the equation. After we substitute, we apply the copy cha-cha on the values inside the parentheses. And lastly, we combine like terms to solve for the final answer, which is 5x minus 6. Given number 2, rx equals x minus 3 and px equals x squared minus 6x plus 9, same thing applies. Substitute, apply copy cha-cha, and combine like terms and simplify. That gives us our final answer, which is negative x squared plus 7x minus 12. Given number 3, fx equals 6x minus 1 and hx equals x squared minus 5x plus 4, substitute f with 6x minus 1 and h with x squared minus 5x plus 4. Apply copy cha-cha on the second function and combine like terms, then we simplify. And that gives us negative x squared plus 11x minus 5. Given number 4, px equals x squared minus 6x plus 9 and gx equals x squared minus 9. Substitute p with x squared minus 6x plus 9 and g with x squared minus 9. Apply copy cha-cha on the second function, which is gx. After that, we combine and then we simplify. That gives us our final answer, which is negative 6x plus 18. And lastly, given number 5, gx equals x plus 5 and px equals x squared plus 3x plus 2. Substitute g with x plus 5 and p with x squared plus 3x plus 2. Apply copy cha-cha on the second function, which is px, and after that, we combine and then we simplify. Our final answer is negative x squared minus 2x plus 3. Moving on to the third function, which is the product of two functions. Given two functions, f and g, the difference of two functions, f times g, is defined by the equation f times g of x equals fx times gx. The following are the steps that we have to remember in finding the product of two functions. First, write the equation based on the given functions. Second, substitute the given values of the functions. Third, multiply the given functions horizontally or vertically by applying laws of exponents. And fourth, simplify the values. Here are the examples of the product of two functions. Given number 1, gx equals 2x and fx equals x minus 1. In finding the product of two functions, since 2x is not a binomial, then we will just distribute it to x and 1, giving us our final answer, which is 2x squared minus 2x. Given number 2, fx equals x minus 1 and gx equals x plus 5. Now moving on to the second example, we have two binomials, so now we can apply the FOIL method. Basically distributing x to x, x to 5, negative 1 to x, and negative 1 to 5. And after that, we simplify it. 5x minus 1x is 4x. And that gives us our final answer, which is x squared plus 4x minus 5. Given number 3, gx equals x plus 5 and hx equals x squared minus 5x plus 4. Moving to example number 3, although they are not both binomials, we can still distribute x and 5 to the second function. After that, we simplify so we can get our final answer, which is x cubed minus 21x plus 20. Given number 4, rx equals x minus 3 and mx equals x plus 11. For our fourth example, we apply the same method, which is the FOIL method. Distribute x to x, x to 11, negative 3 to x, and negative 3 to 11, which will give us x squared plus 11x minus 3x minus 33. Then, we simplify it. 11x minus 3x is 8x. So our final answer is x squared plus 8x minus 33. Given number 5, fx equals 5x plus 1 and rx equals x minus 3. For our last example, same method with the previous examples, apply the FOIL method since they are binomials. Distribute 5x to x, 5x to negative 3, 1 to x, and 1 to negative 3. Simplify negative 15x plus x, that will give us the final answer, which is 5x squared minus 14x minus 3. The fourth operation is the quotient of two functions. Given two functions, f and g, the difference of two functions, f over g, is defined by the equation f over g of x equals fx over gx. When we find the quotient of two functions, these steps will be applied. First, write the equation based on the given functions. Second, substitute the given values of the functions to the equation. Third, divide or apply the different kinds of factoring. And fourth, simplify to get the final answer. Here are the examples of the quotient of two functions. Number 1. Find f over g if f is f of x equals x minus 1 and g is g of x equals x plus 5. The final answer is x minus 1 over x plus 5, because we can no longer simplify after we have substituted the given values. Number 2. Find g over h if g is g of x equals x plus 5 and h is h of x equals x squared plus 10x plus 25. After we write and substitute the given values to the equation, since x plus 5 can no longer be factored, so we put it as is, and for the denominator, we need to find the factors of 25 that the sum would be 10. So we have x plus 5 and x plus 5. So we do cancellation on the numerator and the denominator, and that would give us our final answer, which is 1 over x plus 5. Number 3. Find r over g if r is r of x equals x minus 3 and g is g of x equals x squared minus 9. For example number 3, we apply the same method with example number 2. So we substitute the given values to the equation, and after that, we find the factors of negative 9. So the factors of negative 9 is negative 3 and 3. So the factors negative 3 and 3 will be placed on the denominator, and then we do cancellation. That will give us our final answer, which is 1 over x plus 3. Number 4. Find p over r if r is r of x equals x minus 3 and p is p of x equals x squared minus 6x plus 9. Example number 4. Same as the previous examples, we apply the same methods. For the numerator, we find the factors of 9 that the sum would be negative 6. So the factors of 9 are negative 3 and negative 3. After that, we do cancellation, and our final answer is x minus 3. And the last example, find g over r if g is g of x equals x squared minus 9 and r is r of x equals x minus 3. We apply the same with the previous examples. For the numerator, we find the factors of negative 9, which are negative 3 and 3. And so we cancel x minus 3, and our final answer is x plus 3. And the last operation on function, the product of a constant and the functions, it is defined by the equation c times f of x equals c times fx. These are the steps in finding the product of a constant and a function. First, write the equation based on the given functions. Second, substitute the given values of the functions to the equation. And third, distribute the constant to the quantities in the parentheses and simplify. Here are the examples. Number 1. Find 4p if px equals x squared minus 6x plus 9. First, we write the given and then we substitute p with x squared minus 6x plus 9. After we substitute, we distribute the constant to the values inside the parentheses. Our final answer is 4x squared minus 24x plus 36. Number 2. Find negative 11m if mx equals x plus 11. Write the given equation and substitute. Then distribute the constant, which is negative 11, to the given values in the parenthesis, which gives us our final answer, negative 11x minus 121. Number 3. Find negative 5r if rx equals x minus 3. After we write the equation, we will substitute r with x minus 3. Then distribute the constant, which is negative 5 to x and negative 3. And our final answer is negative 5x plus 15. Number 4. Find 4g if gx equals x plus 5. Same thing applies. Substitute and then distribute the constant, which is 4 to x and 5, which will give us 4x plus 10. Number 5. Find negative 2p if px equals x squared plus 3x plus 2. Lastly, negative 2p, substitute p with x squared plus 3x plus 2. Distribute negative 2 to the values of p, which will give us our final answer, negative 2x squared minus 6x minus 4. And that is all for our lesson on operations and functions. We hope you have learned something from our discussion today. Thank you and stay safe.